So let us start our today's lecture 3 in track 2 on pure mathematics. So in the previous week we discussed real analysis, the basic concepts till the convergence of a sequence, the bounded sequences and some sort of accumulation values. We are going to recall one or two ideas, then we will go ahead with the next idea. So the question is, what is an accumulation value for a sequence? I'll be using that, that's why I'm going to recall. So this is just a recall. What do we mean by an accumulation value of a sequence? Accumulation value,
yes, sir.
also called accumulation point or limit point or cluster point or partial limit. So there are so many words for that. So let's say I have a number A
Subsequence
is called
accumulation.
accumulation value of a sequence, and I denote sequence with this symbol AN. If there is a subsequence of this particular sequence, let me name this A and K, where K belongs to the set of natural numbers, such that this converges to A. It means for a sequence, I call A to be its accumulation value if there is a subsequence of the sequence with this limit. This is one of the definition of accumulation value. For example, I have this sequence AN, which is defined in this way: -1 raised power n. Now this sequence is simply this: -1 plus 1 minus 1 plus 1 and so on. Now let me choose a subsequence from this one, that is -1 minus 1 minus 1 and so on. This is one of my subsequence. And let me choose another subsequence, that is 1 1 1 and so on.
Sir, ये पानी की this subsequences हैं?
Yes, itself. But we are talking about any subsequence, not all the subsequences. We are talking about any one subsequence.
Yes.
So this is any one subsequence, and let's say that one sequence is either this or this. What is the limit of this sequence? -1.
Yes.
And what is the limit of this sequence?
1.
1. And we call these to be accumulation values for this sequence. Accumulation values. So there are basically two accumulation values. One is 1 and another is minus 1. And we say that if a sequence has two accumulation values, two different accumulation values, it means it does not converge. If it is a unique accumulation value, a single one, then we call that the sequence converges. For example, we take this sequence AN, which is 1 over n. So you know very well the terms in the sequence are in this way: 1, 1/2, 1/3 and so on. You take any subsequence of the sequence. Let's say the subsequence I am taking is 1 over 2n. 1 over 2n means n belongs to the set natural numbers. This is like 1 upon 2, 1 upon 4, 1 upon 8 and so on. Now this converges to 0. 1 upon 2, 1 upon 4, 1 upon 8 and so on. Now I'll take another example. Let's say this is 1 over n square, and this is also a subsequence of this, you can see, because the terms in this sequence would be 1 and 1 upon 4, 1 upon 9, 1 upon 16 and so on, and this converges to 0 as well. So whatever subsequence you take, you always get the same limit, or you always get the same accumulation value. We call this sequence to be convergent, and if it is convergent, it has unique accumulation value.
For example, in the sequence, or either in the sequence, I am choosing randomly The value is random.
Yes.
Random. It doesn't belong to any particular formula. So can you say this would be,
No, the first thing is that what is the definition of a subsequence?
Yes, sir.
So you pick a few numbers, they will not converge. So the set of those a few numbers is not a subsequence. What is the definition of a subsequence?
Subsequence.
You choose some nk. This is your nk.
Which follows some pattern.
And this nk itself is a sequence. And this sequence is increasing sequence. For example, I choose nk to be 2k. It means I choose all the even numbers 2, 4, 6, 8 and so on. This is my nk. Now what do you mean by nk? Nk means you will take the second term of the sequence, then fourth term, then eighth term and so on. You call this a subsequence.
Right.
According to the definition of subsequence, this nk should be an
Yes, sir.
increasing sequence, then you do this thing. So the definition of subsequence must be satisfied. So there is an alternate definition of accumulation value as well.
Yes, sir.
We know very well that a value is said to be an accumulation value if any open ball around this contains infinitely many members of the sequence. You make any open ball around 0, this will contain infinitely many terms of the sequence, the open neighborhood for that. Okay, we did what we call Boltzmann theorem in the last class. Its statement is if a sequence is bounded, it means it has some accumulation value. Or if it is bounded, it implies that it must have a convergent subsequence. This is the statement of Boltzmann theorem. And then we did two definitions at the end. What do you mean by convergent? What do you mean by divergence to positive infinity and divergence to negative infinity? And if a sequence diverges to positive infinity, we call positive infinity to be the improper accumulation value for that sequence.
Yes, sir.
If it diverges to negative infinity, we call it the improper accumulation value of the sequence. Sometimes there are two improper accumulation values. One is plus infinity, other is minus infinity. Is it possible? Any sequence
Yes, sir.
with this property?
Set of integers.
Set of not integers. Yes, set of integers, but in this way. Like I write this n
Yes,
times
sir.
minus 1 power n.
And yes, sir.
So you can see the first term of a sequence is
Negative.
negative 1, then positive 2,
Positive two.
negative 3, positive 4, negative 5,
Positive.
positive 6 and so on. You see that if you take this subsequence negative 1, negative 3, negative 5, then this diverges to
Negative.
minus infinity. If you take these even, then this diverges to
Positive infinity.
positive infinity. So if you take different subsequences, you get two different divergence properties.
Yes, sir.
So we call this sequence is two improper accumulation values. One is positive infinity and another is negative infinity. Okay, so let us discuss the next idea, what we call limit superior and limit inferior, and this is a relationship with accumulation values. We can define limit superior and limit inferior in some other words as well, but we are going to apply this concept first, that how can we define with the help of accumulation values. So what is an accumulation value? It's a number such that you have a sequence, you choose any particular subsequence of this sequence, then this converges to A. We call this A to be the accumulation value for that sequence. We have the sequence which is in this way. I choose two particular subsequences by taking all the negative numbers and taking all the positive numbers. Negative numbers converge to negative 1, Positive converge to positive one. I call these two values to be the accumulation values for this particular sequence. And if the accumulation value is unique,
Yes, sir.
we call that sequence to be convergent.
Convergent.
For example, you have this sequence. Now you know very well this converges to 0. But whatever subsequence of the sequence you choose, like this one,
Also.
it will converge to 0. Like this one, it will converge to 0, and so on.
Yes, sir.
So we say that the accumulation value for this sequence is unique, that is 0, hence this sequence is convergent.
Converge may not true.
If it is convergent, it has unique accumulation value. If it has unique accumulation value, it is convergent. It's true.
उलट तो चवा यानी एक रोड अगर मैं हर सिरे माप मा करे सका दो यानी सबसीक्वेंस आरो ना
Yes.
अगर सबसीक्वेंस कन्वर्ट ज्यादा 100% गारंटी या सीक्वेंस पार्ट में कन्वर्ट करेंगे
No, no, no. I'm not talking about this. I'm saying accumulation value unique है.
वो सबसीक्वेंस है ना नंडी नंडी वो जो था खायो दस
What is accumulation value?
0
Accumulation value is you pick any subsequence.
कहीं ठीक
It converges to some value. That is accumulation value. I am saying you pick any subsequence. Any subsequence. They will always converge to the same value. We call that the accumulation value is only one. That's unique. Hence it's convergent.
कंडीशन लगे हुआ
Yes, I'm not saying if a sequence is convergent, then its subsequence will always converge. If subsequences converge, then not necessarily the sequence will converge. So I'm not talking in the sense of subsequences. I'm saying in the sense of accumulation values. If accumulation values are unique, it means only single, then the sequence will converge. Okay, any idea about limit superior and limit inferior? And let me tell you, this is similar to the idea of left hand side limit and right hand side limit. This is similar to that idea, but it is a little bit different because there we have functions, here we have sequences. So let me write a definition. So we know very well we have an L sequence. I'm not writing, we have this sequence of real numbers and an element, and that element is some sort of number, let's say. It belongs to the set of extended real line. Extended real line means it can be R or it can be any member from -infinity to +infinity. So it is called extended real line. You have real line, you include two elements in that, -infinity and +infinity you include in your set. We call it extended real line. Sometimes this thing collectively is written as R bar. It means this value can be any real number or it can be -infinity and +infinity as well. Is called what? Number one, limit superior of an, limit superior of your sequence an, if what happens? If this A is the largest accumulation value of an. So you have a sequence, obviously you can find out its limit points, and the largest among those limit points is called the limit superior, largest of the limit points. Like we take sequence -1 raised to n, it has two accumulation values, -1 and +1. +1 is the largest accumulation value, we call it limit superior, and -1 is the smallest accumulation value, we call it limit inferior. So these are two things. So what is the notation? You write your sequence and you write limsup for limit superior, and you write as n goes to infinity. So this is how you define your value A, which we call limit superior. And how about limit inferior? So limit inferior of a sequence is the smallest accumulation value of an, and I'm not writing the same thing, just I'm writing the definition. Let's say that value is written as lim inf an as n goes to infinity. So this is the largest accumulation value and this is the smallest accumulation value. And if limsup and liminf are equal, we say that the sequence is convergent, because liminf is an accumulation value, the largest one. Liminf is the smallest one. If largest and smallest accumulation values coincide, it means they are equal. It means there is a unique accumulation value. We call that sequence to be convergent. So this is like your right hand limit and this is your left hand limit in the sense of functions.
Yes, sir.
Sir, does there any difference between R or we are writing in small interval minus infinity to infinity?
No, there is no difference in this one. This thing and this thing are same. But you can write this thing, this whole thing, you can write it as closed interval, which is not possible, but it is possible in the sense of measure theory. It's possible, it's called extended real line. Otherwise, in real analysis, we don't have any structure like that. Okay, now the question is how to find out the limit superior and limit inferior of a sequence given to you. These are the definitions. There are alternate definitions as well, but this is going to be the simplest of all the definitions. So let me write that how can we find out the limit superior and limit inferior of a sequence. We have so many methods for that, but I am going to tell you the simplest one.
You see, note the crash video when the both will become equal and this will become.
I have the theorems. We'll discuss each and every theorem in detail. Okay, sometimes the simplest definition that I like for limit superior as n goes to infinity is this one. It is in a mathematical sense, but it's going to be the simplest definition.
Is equal, then equal.
It's going to be the definition for that. Equal means there is some sort of equation or formula, but when you write this thing, it means you are going to define this concept. So the definition is, you have a sequence an, you take its supremum as n goes greater than or equal to some fixed value k, and then you take its infimum when k belongs to the set of natural numbers. So in other words, limit superior is the infimum of the supremums. Limit superior is the infimum of the supremums. This is one of the definitions. And let us discuss what do we mean by this. For example, I take this sequence an, which is minus 1 raised to n. And this is, let's say, an example. And my sequence will be minus 1, plus 1, minus 1, plus 1, minus 1, and so on. What is this thing saying? It means you take the supremum of your sequence when n is greater than or equal to some fixed k. I will take k to be 1 first. It means you take the supremum of the terms after this one. So this or after this one. So what is the supremum of this? 1. Okay. Now you delete first term. N is greater than or equal to 2 now. What is the supremum now? Of the terms except this one. 1. Now you delete 2 terms, like you write n is greater than or equal to 3. First you write 1, then 2, then 3, and so on. Now you take supremum beyond this. That would be 1. So you take supremum at each and every instance. You always get 1. You take the infimum of these values. What's the infimum? 1. That's the limit superior. That's the limit superior. Now we saw that limit superior is the largest accumulation value. You know very well the largest accumulation value for this sequence is 1. This is the simplest thing, that's why I like it. You have a sequence, you write all the terms, and you just see which one is the supremum, that's one.
Yes.
Now you delete first one, which one is the supremum, that's one. You delete two terms, what is the supremum? One.
Again.
Take the infimum of these all the values, you get one.
Means k to be fixed for supremum first.
Yes, k is fixed. Like k is a variable, you put 1, then 2, then 3. You took all these supremums, now you take their infimum. So limit superior is the infimum of supremums. Similarly, what is this? How you define liminf of a sequence is n goes to infinity. So this is nth, this would be sup. Is k is in the set of natural numbers, and this is infimum of your sequence when n is greater than or equal to k. Now what you do? You evaluate this thing first. Infimum of your sequence when n is greater than or equal to k.
Okay.
So what is the infimum here?
-1.
-1. Now you delete first one. What is the infimum now?
-1. Sir.
-1. What is the infimum now?
Again negative.
-1, and so on. Now, of all these infimums, you find the supremum. Supremum of these elements is -1. So the liminf for this sequence is -1. So liminf is defined as the supremum of infimums. Limsup is defined as the infimum of supremums. So this is another definition to evaluate the limsup and liminf of a sequence. How about this one?
या सर हर सीक्वेंस से अल्टरनेट सीरीज से theory verify थी या हर सीक्वेंस या एडिशनल
Verify mana kedi cheti?
ना बट ये टर्म जी लिखिया डेफिनेशन लिखिया तो
Definition here here.
Bounded theorem.
वो आता है पर
Now you take any sequence, you will apply the definition, you will find the limsup and liminf. You take any sequence, for example this. n is 1 over n. What are the terms in the sequence? 1, 1/2, 1/3, 1/4, and so on. Now I am talking about limsup first. So what I will do? I will find the supremums. What is the supremum? 1. Now delete this one. What is the supremum?
1/2.
1/2.
1/2.
What is the supremum now?
1/3.
1/3. So this is set of supremums. Now out of these supremums you take the infimum. What is the infimum of this?
Zero.
0.
0.
So this is your lim sup of a, and sometimes we write n goes to infinity. If you don't write, it doesn't make any difference.
कराएगा सही तो करे
Yes, it's same. Now what you do? You take the infimums. What is the infimum?
0.
0. You delete this. What is infimum?
1/3
No.
Zeros.
What is the infimum?
0
Zero.
0.
Again 0.
You delete 2. What is infimum?
Zero.
0.
So out of these infimums, you take the supremum.
0.
So limsup and liminf are equal.
Equal.
We call this sequence to be
Convergence.
convergence.
Yes.
Equal, but with certain other condition is there. Let me write it. I am giving you another sequence as well for, and that sequence is this. n is n times -1 raised to n. What is the limsup and liminf of this sequence? N times -1 raised to n.
Positive, negative, infinity. Positive, negative, infinity.
Positive infinity is limsup
Yes, sir.
and negative infinity is liminf.
Yes, sir.
पॉजिटिव में इवन सीरीज ही है और में नेगेटिव
Yes. So let us write some of the properties for this. Then we'll be discussing the properties and writing some examples as well. So properties. Number one, let me write these, then we are going to discuss. So, properties are, you may call these theorems. A is convergent if and only if what happens. So, limsup an is same as liminf an. I am not writing n goes to infinity, it must be clear. And these two must not belong to this set, minus infinity to plus infinity. It means liminf and limsup must not be either negative infinity or positive infinity. There should be a fixed real number, and if these are equal, we call the sequence to be convergent. Like if a sequence is limit superior 0, limit inferior 0, it's
Zero.
convergent.
Convergent.
Limit superior positive infinity, limit inferior positive infinity, again that's not convergent.
और लो जी का सीक्वेंस नहीं होता इनफिनिटी
Yes. Divergent.
डायवर्जेंट
Yes. Now we are writing the same thing. The second property is an is a sequence which is divergent, but we always say divergent to positive infinity or negative infinity. If and only if limsup an is same as liminf an and they both are equal to positive infinity. Okay. Divergent to positive infinity.
If I am getting any fixed value, any unique value, doesn't lie in the set.
This is a set with two elements.
Yes, sir.
I have not written this.
Between.
I have not written this.
Yes, sir.
I have written a set with only two
In the
elements.
set.
It's not an interval. Okay. A sequence is divergent to negative infinity if their limsup and liminf are equal and they are equal to negative infinity. So both definitions or both properties lie in this category. Okay, the next thing is that if I have two sequences, number 3, let an and bn be two sequences. So it's okay, it must be clear from here, I am not writing. So we have one property, what we call limsup of an plus bn is less than or equal to limsup an plus limsup bn. Limsup an plus bn must be less than or equal to limsup an plus limsup bn. Okay, what is the problem in this one? What is the problem in this definition? Limsup or liminf can be positive infinity, can be negative infinity. We know very well. What if this thing is positive infinity and this thing is negative infinity? Then we don't know what this quantity is.
Yes, sir.
So we don't know what is this. Then this particular thing would be undefined.
Defined.
Because infinity minus infinity is like never zero.
Never zero.
It's something that is undefined. So we should be careful about this notion. Okay, so we'll be doing examples later to this. I think we should do one example right now. Otherwise, we'll erase these things and we don't have any fixed idea what to do. So I have a sequence an, which is, let me write the terms. It's same. 1 minus 1, 1 minus 1, and so on. And I have bn, which is like 0, 2, 0, 2, and so on. An and this is bn. What's going to be n plus bn? N plus bn means you add the sequences term by term.
Yes, sir.
1 plus 0, 1, minus 1 plus 2, 1, and so on. Now I find this quantity. Limsup an plus bn. What is limsup an plus bn? Limsup an plus bn. It means what is the limsup of this? That is 1. Is it less than or equal to limsup an? Limsup an plus limsup bn. What is the limsup of this sequence? That would be 1. Limsup of this one would be 2. So this is 1 plus 2. So 1 is less than or equal to
3.
Either they are going to be equal or this left hand side is going to be less than or equal to the right hand side. And I think for the liminf we have the reverse inequality. For liminf, if you have liminf an plus bn, it will be greater than or equal to liminf an plus liminf bn.
Yes, sir.
I think it can be verified as well. So I'm not writing these for liminf, it must be clear from this one. So what is the next one? So if I have sequences with positive terms, it means each and every term of an and bn is positive, not negative. Then what is the limsup an times bn? Limsup an times bn will be less than or equal to limsup an times limsup bn. Is it okay? Limsup an times bn is less than or equal to limsup an times limsup bn. What is the problem in this case? Let's say this limsup is 0 and let's say this limsup is infinity. Then 0 times infinity is not defined. You should be careful in this case, otherwise it's okay. There's no problem. Otherwise. Okay, it can be verified as well, either from this one or you may take some other examples. If you say I can take, otherwise I think we should leave it. And what about liminf? The same property. Liminf an times bn is greater than or equal to liminf an times liminf bn. So these are two other properties which I am not going to write. Let's go ahead. So this is all about liminf. Limsup, I think we wrote one thing about the convergence as well. So if a sequence is convergent, if and only if limsup an and limsup bn are equal and they should not be positive or negative. They must be equal. A sequence with liminf and limsup to be positive infinity, we call that thing to be divergent to positive infinity. And the sequence is simply the sequence of natural numbers, and like the sequence n or n square or n cube or n factorial, and these are examples of such sequences.